Hello everyone, my name is Rosa Andini and my partner is Benedictus Kenneth. We are from St. Angela Senior High School. Today we're going to present to you our findings about our Arduino-based pulse oximeter device.
Everybody do activities every day, either at home, at work, or at school. And it is crucial to keep monitoring their heart rates and oxygen level to see if the condition is okay. In this research, we created a device to measure heart rates and oxygen level that is easy to use for everybody in the St. Angela High School facility.
So I'm going to explain about our research methodology. First, this is the steps in our experiment. We prepared the tools and materials and then learned how to make the device. And then we assembled the oximeter and created the program using the C language on the Arduino IDE software. And then we did some rigorous tests of the device and program and did some revisions based on the problems that arose. And then we collected data from 30 subjects using the device and analyzed the data, and then we drew our conclusions. And this here is the schematics of our Arduino Uno hardware. So as you can see, the microcontroller is connected to a keypad, an LCD screen, 4 LEDs, and a MAX 30102 sensor. And then this part here is the flowchart of our microcontroller program. So first, the device will ask for the user's input, which is their age. And then the device will read the measured oxygen and BPM levels of the participant, and it will then calculate the maximum heart rate of the subject. And then it will show measurements based on sensor readings, and then it will determine which LED lights to turn on. So for the BPM, the red light will turn on only if the measured person's heart rate exceeds the calculated maximum heart rate. And then for the SpO2 LEDs, the red LED will only turn on if the person's measured oxygen level is less than 95%.
From the data result, we analyzed that both oxygen levels and heart rates are highly accurate. And from the tables, we can see that oxygen level measurement is more accurate compared to the heart rate. Also, we can see the difference gap in oxygen levels between the two devices is smaller compared to the heart rate, which is more variative. This difference is due to the relativity more stable oxygen level in the body compared to the heart rates that can change rapidly over time.
And so based on this experiment, we can conclude that the Arduino-based pulse oximeter can measure a person's oxygen levels with very high accuracy and someone's heart rate with relatively accurately in a school environment. So for the heart rate, it's not as accurate because of the time gap between measurements of the device. And then the pulse oximeter prototype succeeds in indicating whether someone's heart rate and oxygen levels are normal using the LEDs. And then in the future, this experiment can be made better by improving the measuring accuracy of our Arduino-based pulse oximeter. So in the future, participants can use both the Arduino device and the standard device simultaneously. And then we can add some new features such as a blood pressure gauge and a body temperature sensor. And then we can also replace the Arduino Uno microcontroller with an ESP32 because an ESP32 has more advantages compared to Arduino Uno. It has more memory capacity, it has faster processing speeds, and it has Wi-Fi and Bluetooth capabilities.
These are some references we use in the making of our research, and thank you for your attention.